the assignments are called?
Step by step, yeah.
Assignments took me, I couldn't finish it. I just had to do it. I was just like, no, he's gonna do shit.
It's all this lighting and computers.
Do like a reverse classroom, kind of like do you recommend do like check? Not even checking.
So are you giving recommendations
No.
on how we should do it?
Yeah, first, and then come to class.
Alright.
What do you even need that?
One finger salute.
I thought we needed to.
They do.
I didn't do anything on there. It doesn't mean it shouldn't be connected. You know what, Alex? I don't agree with you. You probably got it already.
Now you're trying to put it, you're literally trying to put it in nothing.
Where is it? Can you put it? I'll put it in. Because I don't make fun of people, I'm not mean.
Trust me, I'm not in any position making fun of anybody.
I didn't bring one.
You do the story map? Story map? I'm interested by he showed us like the Titanic map. Just like 2 cents. That's what I think.
Did you end up downloading it so it's on your desktop?
Hard for it?
Yeah.
You have to? How would you have done the assignments? That was another thing. I was so confused. I just downloaded everything.
Yeah, so you have a bunch of little breaths.
My desktop sucks too. Barely can even look. It's like can't handle it. But honestly, the controllers are straightforward. I just didn't realize like how much. When we left classes Saturday, I didn't realize we had like. Didn't they say art makes you?
Yeah,
the syllabus isn't saying it.
No, it only says
Do chapter 2.
reading.
It says do chapter 2. So I did chapter 2. Tutorials. Here we are. Day 2. Prepaid Monday.
Oh, Monday.
Hey, you don't know about this right here.
No, I don't know because the bookstore doesn't want me to know. He was like, "What's the bookstore?" It's like ordered somewhere else. No, but when you got it on Amazon, it said you get it new.
Was it really out?
No, I wasn't sure.
Alright, give me one more
What
minute. You're
edition
out of
was it called? Like,
Technical issues. Thank you, sir. That's why I said thank you.
I don't like this shit. This is not. Like, I had snacks.
I had any snacks. I wish I had his water.
I didn't get lunch. You're not eating?
Not the last one I was saying, I was speaking. The word lines out to whatever happened there. Maybe I get like one of those cereal. I mean,
I will stack of one snack. I need food.
I'm gonna order my Uber Eats if I get Uber Eats or whatever.
That's a good idea.
No, you locked in, you locked in.
Inhaling it is bad.
Yeah, we should do it early. What's the wishes
We do it during this class.
I get like stuck in so many options so it stinks. It ends up taking me 25 minutes to choose what to eat.
Right.
I wish it was like one of these today. That's it. Those are your only choices.
No, well, I get the same thing, like a turkey burger.
Okay, thank you.
Okay.
From where?
Solid.
Thank you, sir.
Anyway.
Yeah.
I'll have to send you a check in the
All
mail.
the turkey burgers from anywhere kind of
Yeah,
stuff.
dangerous.
I know, right?
Dangerous.
We'll need.
That is dangerous.
Okay, you're right.
There's nothing terrible on Uber Eats.
Yes, there is.
Yeah, of course there is.
They're like fast food. Okay, this isn't a fun one.
I don't know.
Like, it looks like one of those things that go on the chair. You know?
Really? Maybe.
It's like real. We did. Sorry. No, other thing. It was weird. What about this? Yeah, that.
That word is filter.
What's the best contrast for you guys? That?
Same way it's submitted right
So you're
here.
following your guys' Steve, huh?
This.
Dark by the
Yeah,
screen.
I'm in my own. Filled it in.
Yeah, I just didn't need too much.
Yeah, that's going to be fast before you.
I know.
So I just assumed
Alright.
Me too. It's first day. It's just
I need to step up.
And what?
We start to see how the vibe is.
You need to lock in.
I'm like talking now, so you guys
Sorry, I hope I'm
Saturday I was
pronouncing
talking
it
to
right.
you, man. On
That's
Friday night, I was
fine.
there. She was like,
Rework myself, get ahead early, and then repeat those same projects. Because I'm lucky I don't have a full-time gig, so
I was like, I don't
so
know.
we need to be in one office so we can do it together and really make sure we're getting ahead. Because then if something happens, we're on time and we can get ahead, so we can slip up a little bit and be on time. I'm just
I gotta get your number.
yeah.
This is not, I don't think anything's working.
Turn it on and off.
The only computer.
Turn it on. And then you turn it back on. Oh, I am definitely very right. I'm not the problem.
I think you just broke it anymore. Now look.
No, hold it.
You don't need a holding gun now.
How do you know?
Because you just turned it back off.
Yeah, it's on now. Like,
Stop blaming me.
I'm trying to show you all the work I did last night.
So the whole downloads that he's talking about, they're in this computer.
I think they all should be already here. That's what I was.
All the downloads that he wants us to do on my computers and on these computers. Right?
I don't know.
Oh yeah, makes sense.
You would assume they have all the assignments on this computer.
Or the software.
Whatever. They have definitely the software, but they also probably have the assignment, you know, like the folders. Or do we need to re-download those?
Or the data files.
Have you guys
You guys
checked
said
the last week's video? Was that good enough quality in terms of screen capture and voice? Didn't look? Did you? Right?
I didn't watch over it. I watched it the first time.
Right. Then we will wait or not. Let's do some fun stuff. Let's do class. Presentations. Here we go. Gotta do roll call. Last time we're doing roll call. Let's see if I find my students by list. Anthony.
Like say anything.
Not here.
Well, he's like, what's your name?
Miriam's here.
That's your fruit.
For the other class? Oh, we got a new girl.
Go by Alexander. By
Nah, Alex.
you want me to take them off?
Mo is sitting over there. Summer, Mr. Bruce Fleming.
And then you go into the book, and you go to tutorial 1 and it tells you,
See, this is how I remember people. Spatial patterns. She's sitting exactly at the same spot, right next to Erica. Christina.
So then we download this program. Actually, right into our computer.
Mr. William.
This is not working.
Nathan's here, Ryan, Benton, Brianna is sitting in the second row this time, Mike is in the first row. Jack. Hi, you. Chris, have I seen this yet? No. Alana was there. Okay. Your hair is different. Your base is different. And Max. He was here too. Cool.
Oh, Anthony isn't here.
See what?
Why isn't he here?
Oh,
See what? Oh yeah, I know. Oh yeah. So what we're going to do today is we're going to have a lot of fun.
This is what I went last time.
Need to find a way to separate.
And we're doing this.
Wasn't it?
I think usually the underscore red.
Right. Okay.
We did finish the PowerPoint slides. Did we do Census Tract feature classes? Alright. Yeah, I think we did because it's a really bad quality slide. So just to give you an overview. We slice and dice. Hi everyone. Good morning. Gotta wake up. If you remember, we can slice and dice the real world into GIS, into layers, or rasters, or other ideas, as in, let's say, vector data. What is vector data? Points, lines, polygons. Very important to remember. It's like your handy tools of the stuff you really need. Yeah? So, because all of these have different relationships with each other, a point, as in a single post for a sign or a fire hydrant, is different than a soccer field. You know, because a soccer field, yes, I could point that soccer field as a point if I'm like looking at the whole county. Yeah? So I would use a marker to show that location in shape of a point or something like that. Yeah? Versus the real physical space would be a polygon. Alright, so if you do that, polygons do certain boundaries or setting framework. One of the frameworks we're looking at is, let's say, the continental US, yeah? The whole country. Then the next framework you go down, or next level you would go down to slice and dice this, is states, counties, zip code areas. Then there's something we call census tracts from the US Bureau of the Census. If you have no idea about that, you pretty much heard it maybe in last year because they had a huge discussion about changing questions in the census. Yeah? Because the census is a nationwide survey of the current state of the people in the United States. Yeah? I'm not saying residents or everything else, it's the current state of the people. Yeah? That means whenever you get that survey form, fill it out, be honest. As a graduate student, probably if you don't have a real world job, your income is probably not $1 million. Yeah? So, but that means I can slice and dice a country or us into census tracts. The next part would be census block groups. Then I go even lower and go down to like street block level, a census block. And depending on how detailed I want to have my information, I can extract it from that database. Census webpage, census.gov, it's huge, it's fantastic. It's also so big that you can get lost. So I do encourage you, particularly for the real estate market analysis class, to spend a few moments on it. Learn how the search function works, how you look up things. Why is this important? Even if you are not using it for GIS purposes, the tables and information on the Census Bureau are vital for your work. Not knowing how many thousand people are living in your county, if you go into a, let's say, regional discussion meeting, gotta know a little bit your base mark numbers. Huh? So that's the reason why we're doing these exercises in other classes where you say, hey, take a look at this other county. What are the employment data? What are socioeconomic variables? And today we are doing, speaking of socioeconomic variables, today is the mind-blowing day. Because we're changing a little bit gear and we're taking a look at Business Analyst Online, a gadget which we usually would do in the fourth week. But with all the technical issues we have experienced this week, and some of the books are not there, and please, yell at the bookstore. If I am late with submitting your grades, you can yell at me. You have the same right to yell at the guys who are not able to deliver on time, repaid, your work, your study stuff. Now, this is unacceptable. You can quote me for that. I have to put in my books 4 or 5 months ahead of time. Like literally in September, October, I will be asked what do you want in March. There was a change in the system, so we did that over summer a few times. I had to change a book or so, but it's unacceptable. Yeah.
So you need us
I
to say
have at least 2 or 3 students, at least 3 students who actually do not have the book. I think one, I remember who was it last night, sent me an email that the order in the bookstore was canceled. Yeah, unacceptable. That's the reason why we changed a little bit class today. That's the reason why I'm running on fumes, because I changed my class session completely last night. Yeah. It's going to be fun. That's all what we're going to do is we play a little bit of ArcGIS Pro, but we're playing mostly in a web browser. I would recommend Chrome on these machines. Yeah? So we're jumping ahead a little bit of time, which can be a little bit overwhelming, but the technical skill we're going to do is less overwhelming than the installations on the computers, okay? Because we're pretty much playing in a web browser and shifting things around and have enough time to explore. Mission goal for today is all the frustration you had in the last 8 days with GIS should be gone by noon. Like you leave today and it's like drooling over the ideas what you could do in that web browser. Okay? Now imagine what you can do if you create your own data. Cool. So Census Tract is one example. Then we have civil divisions or political boundaries. Here is actually counties and cities. Yeah? So Broward County, MDC, West Palm, all the cities included in Broward County, they have their own boundaries. Yeah? Even though you sometimes really do not realize that you are in this, or moving from one to the other place, you can map that out. If it's just simple, a yellow versus a red on that list, on that map. Yeah? So next time you drive around campus, if you're on university, you're going north, the moment you pass Whole Foods and go underneath this 595, you're in Plantation. There's no big sign, welcome to Plantation at that time. You go south, I encourage you to take a look as when you go in, on the right corner where I think it's a Jiffy Lube, and then Whole Foods, there's actually a sign, welcome to Davie. And there's a sign about we are horse riding friendly and biking friendly. Yeah? Think about that. Perception of your space changes. Okay? So we can use this, and usually the civil divisions line up somewhat with the zip codes and the census tracts, so census block groups. So you can do what we call spatial analysis and say, hey, if I'm here, what's down there or close by? That's the power of GIS, because you can relate objects and relationships across space. All right, schools, as an example here for administrative, little blue dots, giving you the idea of where are the schools located. So apparently we only have one here and a lot of here. Not knowing the context of the state, area, or whatever. What impression does this map give you?
There's more population than it is.
Why do you think that?
more space.
You need that many more services.
Right, because a school is somewhat associated with population density of school kids. Yeah? So the higher the dots, or the amount of dots, aka the density in this area, you would think, okay, fine, and I would certainly concur to that. Yeah, good observation. Same thing here, we'll go through this. We did this last time. Yeah, we did that.
Oh, we did it on the program.
I'm pretty sure you're polluting companies.
Oh,
All right, well, a small display of how does this work, how does this look like. Again, political boundaries and a specific, in this case, a specific research point of where are my polluting companies? So you could say, according to the EPA, XY company is the polluter, therefore I can flag them and put them on the map. Yeah? So instead of saying DuPont or Monsanto or Mr. Smith Johnson, yeah, to make up names here, not to point out a few, are a polluting company, you have no idea where in the state Mr. Smith Johnson is located. Drop a point, you might be able to do that. If you put a label to it, even better. If that's the purpose of the message. Here, the message is, the schools showed us a high density of schools. Huh? Here we also, I would say, this is the highest density of polluting companies in that area. The name of the company doesn't matter in that case. Huh? Because you should take a look at, Chris, we're doing like a little bit on local installs, and the last row has not that software. So if you can choose a spot somewhere here. And all right, same thing here, water features. Those are polygons. Give you an idea again about point, line, polygon. So I can now say, wait a minute, I have here some lakes, I have here a river going through, and I have a bunch of polluting companies at the river. So probably they're doing something with the river, if they're not polluting the air. All right, features. Oh, I can skip this because the next lecture is completely about that. Something to point out here is you can actually see on the, what we call a base map or background, you can see somewhat a nuance in gray going down, and we will do this on our own computers so that you can see. The idea of nuances is to show that there's actually terrain, like a hill, and you have like a slope going down here to the river. Yeah. So if you take a look at the aerial photography here, United States Geological Service is USGS. You can see here, this is kind of that hill thing, and then here you have the river. And it does take, even in the age of Google Maps, it does take a little bit sometimes to read into an aerial photography, depending on its quality and the resolution. Yeah? So it's super easy sometimes to say, well, this is a street, this is a river, but then what's that here?
Rail?
That could be rail, that also could be a dirt road. Based on that resolution right now, I don't know. Looks like rail, but see, then here, this is more a dirt road. Yeah?
I see you're mining there.
So this is winding here. This could be a rail for sure, because they need to go in a certain radius and a certain level. Yeah? There. We did that because I showed you the guys in 3D picture. All right. A little bit of tooling. 3D. What you can see here is like simplified and so-called extruded models. So basically what went down here is this is a boundary, could be a building, could be actually a census block, yeah? And you have a height associated with that. And based on the height, this is the tracts, census tracts, with some median income. You can see that barely see that here. This is median income, and then you can see here in Minneapolis there's certain areas in census tracts where you have higher income. So you can use that 3D visualization to show, hey, there's more money in that corner. Yeah? Very cool. Typically what you would do is you take a cloud breath map, what we call that, and show the gradient colors just in 2D, which is fine for a report. This is just, forgive me the language, this is just pimping it out in 3D for visualization purposes. It's like, hey, look at this 3D visualization. Yeah? Again, think about the message. Is that a meaningful way to present your data, or is it just a gimmick? Yeah? It's cool if you animate it, but that's it. All right. So a little bit of reflection of what we learned last week, and what we will tackle more and more and more. Remember, GIS puts things, objects on a map. It's not mapping, it puts things on a map, but the power is that attribute table in the background. Think about the Excel spreadsheet on steroids. Yeah? you have the map, you have these features here, and each of those selected, this is polluting companies, are highlighted now in the table that shows the location and the pounds of pollution, etc., and even the name if needed. Yeah? The power of GIS is the quality of your data in this table and the location. Yeah? So you can mess up a lot if you say this company here is actually located here. So you did something wrong in what we call geocoding, putting an address on the map. Yeah? Or you say this is 20 million, although it's 2 million because you had a typo in there. Yeah? So gotta be careful. Rule number 1, if you get external data, always investigate it. Do not trust even your own data unless, how was it in my old statistics professor? Don't trust your own statistics even if you fake them by yourself. Yeah? Yes, Angelo?
Is the geocoding done with lats and longs?
The geocoding can be done with any coordinate system you want. Typically, lat long is a standardized version because it goes with the UTM coordinates, GPS coordinates. Yeah? That's kind of the international conventions to set this up. We have a theoretical session where we talk about map transformation and map projections, because you put the 3D curved surface of the world into a 2D element. Well, the Earth is not equally curved. Yeah? By concept, it's a sphere, it's a ball rotating. And some people will say it's actually not really a perfect ball, it's actually a little bit flattened and the poles on the top and on the bottom of the Earth, if you make simple characteristics. I hope I do not offend any religious beliefs in here. I did that in the past when I mentioned that the Earth is not completely round. Yeah? And the next one is you also have hills on the Earth. So how do you map hills if they go up like this and go down like this and in 2D? You have to come up with a certain nomenclature, a certain convention, how you map all these. And then, depending if you're closer to the North Pole or South Pole or to the equator, the way you would map this out is changing. There are different patterns and different issues in terms of scale and distance. So we will learn later in this class that depending on how I project a map on a screen or on your table, the distance between New York and LA can vary by a few hundreds miles. It's still the same distance, but I'm drawing it slightly different. I have someone made earlier that comment about making wine. And man, this was very strong. Changes your perception. Yeah? Transformations and projections are the same thing. Yeah? They change a lot of perception. Because you could, let's wait for the lecture before I tell you the wrong things. But it says, usually there's this fun sentence, projections make geographers sad, S-A-D-D, because they change shape, area, distance, and direction. There are 4 elements that actually can get twisted around with projections. It also means if you are putting the projections not in the right sandbox, if you don't have the right types, they don't play together. Yeah? Best example, you can have a baseball team, or what was it? You can have a football team play in a baseball stadium. But you have to make arrangements to the stadium so the team can play. Yeah? So not every baseball and football team and the stadiums will work out. And you need to know that, because you just can't go then to a baseball stadium and say, draw me a 50-yard line. You have to make those adjustments. So maybe you get a pop-up sometimes as, hey, the spatial transformation or spatial reference is not fitting. Yeah? Hold your horses, breathe, no panic. Depending on what you want to do, if it's just displaying things, I wouldn't be worried because your system is doing it on the fly for you. If you want to do serious spatial analysis, you need to make sure that they're all in the same football stadium. Yeah? Even switch gear. Like, get out of that baseball uniform and get them some shoulder packets, or whatever, pads or whatever you call it. I grew up with soccer people, actually volleyball and biking, so I have no idea about football, how you call it, uniform stuff. All right. So again, the idea here, you see this today as well in the online version. You can now change the intensity of the polluting companies with so-called gradient symbols. So the higher the pollution, the larger that marker or symbol can be. And you also can show other elements here underlying in the background. Context information, as we call that. Yeah? Then we also can do statistics. Basically saying, okay, fine, you have here what we call a buffer, that yellowish line here. We say within 2 miles, and then you could actually run some statistics and calculations. Be very careful with this. It's super easy to make false statements and get misinformed. Remember the slide we had with the telephone households?
Yes.
Same data, 1 or 2 mouse clicks in the wrong way, and you have a complete different message. Yeah? I would like to know exactly how we came up here with the 23.25. Yeah? Again, but this sentence, 2 paragraphs, gives you more information than the map. So as a closer of the idea of map versus visualization, remember, Lesia, a good paragraph is sometimes better than a map where you're like, what does this mean? I have no idea. Okay? Tell you, that was the close for this one. Let's wait with the fun. Let's see if this works. So didn't I click on this one here on the side and that out didn't? Well, in this case, I'm trying to get screen capture from this computer and web camera talk, but apparently I don't know exactly how to do that. So that's okay. So we already did a dive in and review. In case you don't remember, my name is Dr. Thomas Würzer. I am your professor for GIS. And you can figure out sleep deficit is high, caffeine is kicking in, and I want to make sure that we're going to have a lot of fun today. We are doing following changes. If you look at the syllabus or the schedule, what we're going to do is we're playing with the desktop to more online GIS, and in week 4, but we would do it actually like in 2 weeks, the business analyst online. We're going to take that today and come back in a slightly different fashion. Why? Because we are frustrated right now with this whole class, with the book, with the lecture. It's Labor Day weekend and you are here and you have to listen to me and all that. So the only great thing is that it's really miserable weather outside. You can't hang out in Key West and get a sunburn. Yeah? So that all said, we are moving this a little bit around. That also means that in October 6th, week 7, the spatial workshop as business analyst online, we will have a little bit more time and content there as well. No panic, don't worry about that, that's completely okay. Having a little bit more exposure than planned to business analyst online feeds 2 purposes. It's the most used tool after you finish this class. The last 2 years we're teaching this class with business analyst online for the students, accessible for the students. It's the most used tool. Why? Because with just a few mouse clicks you can get a market report on anything possible, like crazy stuff. Today we're doing the first steps of the crazy stuff. Yeah? So to have this more and more as a repeat is great. In the past, I had an assignment just about business analyst. Guess what? I kicked out that assignment compared to last year. Now I'm going to put this new version in. Why? Because next week we have an assignment due. So everything what we're doing today will be in the online GIS world. Maybe 1 or 2 clicks in ArcGIS Pro for educational purposes, but not part of the assignment. So the assignment you can do on any computer in the world that is a web browser enabled computer. If you have an Apple, I'm not 100% sure about 100% of Safari, but there are other ways. Yeah? If you don't have any computer because the house burned down, well, we are in a hurricane area, not in a house burned down. You can go to the library and log in into a computer. This is very important to understand. ArcGIS Online and Business Analyst Online, which is an application on top of that, is online based. It's like your online banking, like you order, well, that's an Apple app, iPhone app, like ordering your tacos. Or remember back in the days when you went online and ordered Domino Pizza and they showed you the Domino Pizza tracker? Yeah, this is what you can do in the browser. The reason why I'm so diligent about that is you need to understand, you can do that from any computer. You don't have to do this on a little tiny laptop. Yeah? If you have a fancy computer at home, a fancy TV, smart TV at home, you could do that on the smart TV at home too, like this big guy. Now, I haven't done that, but I think there is the capacity to do that. Yeah? But okay, so what we're going to do now is, I want to go through the classics of map design visuals to close that idea of the theory of visualization. The theory of coloring things so they look a little bit more pretty and more decent on the screen, aka meaningful information rather than just cluttered data. Yeah? And I call this we did bad things. GIS and mapping and visualization is a learning curve. And I have a few slides from my past where when I'm done with that presentation you laugh and you're happy that you're at the starting point, or you're completely frustrated and actually drop the class because you think I'm nuts. It's usually the first part. It's the first part. A combination of my work, combination of my bestie, and I told him like a few years ago I'm going to use those slides in a bad PowerPoint presentation. I should have told him this summer when we saw each other again that I'm still using it. We'll do. We'll call him later tonight. It's not going to be a Alright, so map design. A little bit overview. We are here in the strategic circle of navigating through maps, map design, basically using and making maps. First row, starting out. And then the idea is switching the online elements a little bit. We're touching a little bit 3D today. We're going to take a lot of proximity analysis. Network is included with that. We totally disregard all this today. Focus is here on map design as part of a theoretical lecture. Alright, what does this mean? Light versus dark colors. So I can say black is 100% black, everything else is a bunch of shades of gray in between. But depending on where and how I use this map, grayscale or colored tones here is different. Because intuitively I perceive the darker color here as a higher value. If you consider that, it's 100% black. 50% black would be something like this down here. Because I have those different gradients of color. Super simple thing, but we accept that every day, but we never really talk about how important that stuff is. Same thing like with contrast. Best way to deal with contrast is you look at this screen, you look at my computer screen, different contrast levels in the technology help. But also I can say This is important, this stands out, this is rather in the background, this is context. The next few slides is really about the idea of putting things right in your face or give you context. Now, this is the best example, right in your face versus context. I can put 5 dots on a map. If I don't put a street map underneath it, you have no idea where it is. What's the context? It could be islands, it could be dumpster trucks in a neighborhood. That all said, this map on the US counties, and this is census data. Census data usually comes a little bit cryptic. That's the age group of 65 and up over the population of 2000. So it's a little bit dated, but it's the same principle. Giving you the idea of this density of old people. I can say that, I'm closer to that age group than you guys. In the US, well, you can see, yeah, there are some spots, but maybe the color ramp is not so great and the contrast is visible. This is the same information, just differently packaged in contrast. Did we do this right? 5 groups, very, very white, so it's just lime colored green. Here, very light, but really darker. So if you think in 10% steps, this part here jumps a few percents in between, but it shows you more detail on where are actually the hotspots of old people. We're here. This is us. So West Palm is actually a little bit higher in that concentration, or was 18 years ago. All right, super simple. Same thing here. Think about what's the visualization here for the messaging.
Saturation.
Contrast.
Contrast. This example is just for contrast. But also you could say, do I need actually the state lines that big, that thick, or depending on what's the research question behind that map, I might actually drop the state boundaries. And just say, here, look, there are certain cells or certain areas of higher density. Because in this area here right now, the state boundaries are actually taking away a little bit from that idea of messaging. But that's nuances, that's like fine-tuning stuff. Again, I'll present a PowerPoint later on that's called We Did Bad Things. So all of that is a learning process. All right.
I'm sure it would work.
Minimize ink. Edward Tufte, I've showed you a few pictures and design principles. He's a really cool designer guy. Argues minimize ink. Meaning back in the days when we started drawing things, ink was expensive, but that's not really the point. The more ink you put on there, the more cluttered you get. Remember that New York picture with the subway and the photo dots and all this other information? Get rid of the useless stuff. It's really hard for a student to actually say, I'm doing 2 maps instead of 1 with everything. Or have 1 small overview map and then more detail on a full page. Remember that. The leap of faith to do 2 or 3 maps as a map series, yes, it takes space away in your document, but it actually improves your message if the message is transported through a good map. I'd rather have you do 2 maps and have distinct demonstration of your skills in other classes as well, than 1 cluttered map nobody can decipher what's going on there. If you look at the map and you say, what did I want to tell here again? Write a paragraph. Or redo it in 2 or 3. All right? Minimize ink means be clear, be eloquent, and concentrate on the message. Lots of white space. All right. Graphic hierarchies. This is like 5 slides, and then you're like, wow, never thought about this, and this is so simple. and then you do it on a computer and like, I missed that. Place a strong boundary, such a heavy black line around points or polygons. Again, this is a polygon. And you increase the importance. That depends on the scale of your map, where you at, like zoom in, zoom out. If you do counties across the United States and you have really strong boundaries, the boundaries will show up, but not the fill, what we call here the fill, yeah? Because the way the map is drawn on the computer screen, you will see that. Then you also can say here, the crosshatch, you actually have a different idea now for symbology. This could be an overlay. And saying, hey, this is wet zones or preservation or something like that. Something that is not yet completely solid in place. You'll see land use maps and zoning maps which are solid colors. Yellow for residential, blue for office as an example, yeah? And then overlays are like, hey, you can do a few things in between.
So you would say that the crosshatching there emphasizes one purpose? Is that
No, you can, this is,
or just that there's a difference?
there's a difference. And based on the fill here right now, this is more fill. Yeah, so I would, if I look at these, this is more important than this one. But again, this depends where you're coming from. Yeah? Again, the example is, I would consider this as an overlay zone, that something is covering an area, and this is something solid being on the ground. If you look at Danny here, for example. All right. I like this one. So what's the important message here? Anyone?
But it's easy to see the points that fall on the grid, like the ones that fall on.
Right. So the grid gives us context. So somewhere grid to have accounting functions or something, accounting for, let's say, crime, burglaries. But are the squares or the dots the important part in that map? Are they equal?
I think they're about equal.
We have no idea what's more important.
Yeah,
Based on how this is used, so-called figure, we have no idea. Why don't we just say, you know what? I actually want to differentiate, let's say, between personal crimes versus property crimes in an area. And my message now is saying, you know what? If someone gets mugged or shot at the street corner here, this is way more important, let's say, for criminal justice, than there was a break-in and they stole a watch. Makes a huge difference. Just a change in coloring. Complete change in message. Now you say, wow, what's going on here? Yeah? Important parts is in the circles, and then everything else is in the background, giving you context. Or, yeah, ground. Context. I prefer context besides as ground. Yeah? So keep that in mind. Same thing here.
I think I know.
Minimizing. I don't care about the little things here in all these colors and the streets and boundaries of the neighborhood. If crime and type of crime is of importance, well, and put everything else that is not important in the background, or get rid of it. Huh? All right, bad map, chart chunk. Population of cities in 2000. You see a legend here. Please do never ever write legend on that. It's clear that this is the legend.
That's so bad.
It's like you would write on top of a book. Book. If it's that thick, if it's hardcover, it's probably a book. And if it's wax, it's a book about ducks. So, has a name on it, this is good, not necessarily always. Has a scale bar on it, which is great. Then actually descriptive text, what an inch in this display actually means. I can't really picture 53 miles, 0.26. Not so sure how many square feet, how many feet that is. Yeah, but we have a north arrow here, which is nice. Again, idea of what's going on. But what's going on in here is holy moly. Huh? State boundaries make sense. We see Pennsylvania, Maryland. This is actually nicely done because it has the so-called halo. Like, see that little, there's an offset with white, so it stands out. We can read it better compared to all the other little towns. Why would you place all those names of the little towns if it's just about populations of cities? But then, oh, look, population in the cities as graduated symbols. The larger the area, the bigger that marker or symbol. But why, if this is population of cities, why do we display counties in here? Again, this is an example when you should do two maps. One about the cities and one about the counties. So if you clean this up, look at that. Just remove a few things. Now you have the population here, you have still know where it's what, yeah? Or we cut off the map elements here with the scale bar and all that. But it's clear that this is about population. You could also argue the way these symbols are drawn on the map is not the best because the big ones, you might want to make sure that they're drawn the last time because everything is drawn in an order. And you want to put that big one on top. Yeah? Think about it, you have one big one on the bottom and you have like 50 small ones uncovering the big one, you won't see that. It's like if you walk at the beach and you have your feet in the wet sand and you throw sand on your feet. All the little sand, the sand grains, that sand will cover your feet. The feet are the biggest object what you see. You know? How was that? That was a foot example, not
great.
a food example.
Not great.
So it's too early to talk about food.
2 out of 10.
All right, color. Someone earlier said saturation. Yeah, was quasi right because saturation is the brilliance and the intensity of a color, but typically somewhat we consider that more as the color scheme, in the color scheme, not as in the black and white idea. Yeah? This is not a design class, this is not a thing where I'm going to sit down and say, hey, what's the complementary contrast in colors? And you need to know, oh, it's red, blue, red, green, blue, yellow. No. Yeah? The idea is to give you visual examples that with different values of saturation, we can create different visual statements. With that, we can also weaponize our data into information and push the information in a certain direction. Not that we are going to misinform people, but depending on what's your outcome, what you want to convey as a message to the reader, you might change different colors. Red is not always the best to highlight things that are important in a project. All right, speaking of contrasts, here we have the complementary contrasts and all that, mix that up. If you have issues to see the red and the green, particularly the male population of this class, you might want to check that out. It's a common thing. It's not the best test, but some people do not see colors the right way. At this point, I make a joke usually that I'm colorblind, and everyone's like, how did you get to 2 degrees with colorblindness and GIS? I'm like, well, that's my poor attempt for a sense of humor, but it's okay. All right, monochromatic color scales. This one has to show you. You look at this and say, fairly, I knew that, you know. Different color schemes, increasing color, or saturation of the color makes sense, huh? So the reason why I say monochromatic is because we also have dichromatic colors. So where we can actually mix up a few things. I think I have examples for that. It says here 2 monochromatic scales joined together with a low color value in the center and color values increasing both ends. like that. This is an example on forest fires, yeah, where you see here on a map that shows squares for a grid unit, so you have an overlay and you can say, hey, in that grid we had a change. And now you can see, okay, the numbers of forest fires where they decreased and where they increased. Yeah? So intuitively, just use now the two color schemes, and the instinct of blue is cold and low, gives you a cold feeling, versus red is hot and high. Yeah? Kind of ironic when you talk about forest fires, because that's pretty much the case. They're burning rock, better than that, and they're really hot. And in case you haven't figured it out, I used to do some work on wildfires, so there's a bunch of fire stuff here and there in my talks. But this is a super easy way to show change over time in a system. This is one current state. Now think about that. We have every morning firefighter briefings. In the case of we actually have a wildfire somewhere, and there are early morning briefings where they actually talk about how to attack the fire. And there's a status quo report. Now, based on that, at least that one morning session, the next day is decided upon. So you could now go in and say, what was it 4 days ago, 3 days ago, 2 days ago, yesterday, today, and hey, do we have someone who's actually able to predict the change? Is there a way to model that? And Esri did a good job on a fun job with that in the past years. So again, different dichromatic maps here. Again, as an example, this is Allegheny County, Pittsburgh. Yep. And the percent change in housing units, which was yep. That's actually the negative example. Red is a negative here. Now, blue is actually a positive. So really bad math. Because you would think, oh look, all the housing units are taking up. You know, actually this is a negative sign here, minus. Which is also interesting here, zoom outs for these areas of interest, but they're not indicated in this larger overview. So you could also say, you know what, if these three areas are your focus area, why don't you do this as black and white? Yeah? And then have an arrow or some visual aid that draws out to show you where are these areas of interest, because right now, I don't really see them. And even without classes going closer, I don't see them. And you probably need them. Yeah? So think about this. What's the message here again? Do you need an overview that big if you want to actually focus on those three zoomed in areas? All right, color tips. Colors have a meaning, political and cultural. Remember that. Yeah? So we have a political spectrum being mapped out as blues and red states. That was by accident at certain time apparently, but they still do that. Yeah? Cool colors are calming, appear smaller, and recede. The calming part is interesting. Cool colors, perfect example is dark blue. Dark blue has something fascinating. Yeah? I can tell from own experience as a diver, if you have this massive, wonderful blue at 100 feet of depth, and the yellow fish is moving by, this is one hell of a day. Huh? And you turn around and then you have a reef shot. Again, cool colors, calming. There's a saying about the deep, so-called deep blue, and people are completely disappearing in that. That's really cool, I have to say that. Warm colors, yeah? Just saying warm colors, so you think, ooh, it's orange, yellows, and reds, something we really don't know here well, is a fireplace. Imagine a fireplace. All these colors, and you're like, ooh, cozy and warm, sitting on the couch drinking a nice eggnog. Yeah? Christmas, snow outside, Christmas tree inside, warm and fuzzy. Yeah? Warm colors, exactly red, yellow, orange, very strong in the instinct of perception. Yeah? How would I map temperatures? Blue, ice cold, red as warm, extremely warm. How do I map winds and predictive winds? It's hurricane season. Yeah. Cyclone 6 is coming, but she will turn, hopefully, in case you haven't seen it yet, Canary Islands. And National Hurricane Center. It's 1st of September, check it every day. Cyclone 6, and it's now a depression. Or tropical storm. I checked it last night. But the prediction is turn north even before it hits the Caribbean. So wind and air quality sometimes does not work out in terms of going from yellow into red with certain stages of that, because it's alert stages of air quality. There's also purple. If you go into purple, then winds, I'm not an expert here, it's dangerous. Red is already dangerous. If it's in air quality with wildfires, stay inside, switch off your AC if needed, if you draw air from outside. Don't let the kids play outside. School is probably canceled that day. So, warm colors do not necessarily symbolize excitement. The moment something turns purple, it's probably a life and danger risk. If your fellow student turns purple, please call 911. We have an emergency. It's not a mapping exercise. Okay, symbolizing points. This is important because, yes, we have point lines and polygons as vector data. That is our type of data we are saving this. I can use these points, I can put squares, I could put faces on it, I could put 3D bus stops on that. Because everywhere where you can see right now this point here is the physical location defined as an XY as point. But I can draw on top of that what I call a marker or symbol. That's the confusing part. A point can be visualized with a marker or a symbol. Could be a point on top of it. Could be like my fist. Could be my coffee marker. It's still the point location. Yeah? In 3D, that point location could be a whole tree. Could be a house. Yeah? Can be anything I want to choose for the visualization of this location, defined in that point. Okay? Everyone's like, say what? It's 9 o'clock and he's talking about that? Give me a moment. GIS is about location and attribute data. So now we know that there's a truck arrest, there's a burglary resistance, trucks, etc. Yeah? So now I can actually use shape and color for each of those points on that map and symbolize them with different markers. Here, burglary versus truck dealing. Yeah? This is a crime happened. This is more specific. It differentiates. This is certain types of crime happened in that area. Let me show you which two types in that area. Crimes in the area, two types of crimes in the area. Yeah? So I can assign symbols or symbology for this and have more detailed messaging on my story I want to tell.
If you wanted to conflate the two, you keep it the other way, right? So if you wanted, the story you wanted to tell was, I said the 90% of the crimes were traffic violations, and you had one murder.
Yeah, you can do that.
You conflated them, no, you wouldn't know whether they were all murders or whether they were all traffic stops. To get a
That's here.
point across.
Yeah, that's here. You have no idea what's below the surface. You just see things bouncing on the surface. Here, you put different color codes and shape code here to express what are the different types. And you could go even further and say, if it's drug dealing, what type of drug dealing would it be? If it's, let's say, weed versus heroin. Yeah? If you would have that in the arrest record, as an example. So the better you're doing your survey data mining, getting the data in, the better you can map this out. Example, if I would ask, this is more from a social science part, if I would ask you 2 questions in this room, please note your gender, yeah, and note your year of birth, versus note your gender and in which category of age group are you in, and say 20 till 30, 30 till 40, 40.
Sorry.
It was the computer, not me.
And then you say 40 till 50 and 50 above. If I go in with so-called aggregated data already, with giving you those intervals, if you're 25, you're in group 1. I will never be able to differentiate by gender and filter out the 23-year-old male or the 28-year-old female. Why? Because I never surveyed that data. I never acquired that detail. Same thing here. If I only know drug dealing and not the type of drug, I only can report drug dealing at this location, let's say here. I cannot say this was 2 joints and this was 10 pounds. Depending on the county you are in, it's daily use. So be accurate. Let's say it like this. Right now, I don't think that you're in the middle of a field survey where you are going to absorb all that information for your work. Yeah? But keep in mind, let's say for census data, if you do age brackets, you cannot so-called disaggregate. If I only ask, are you below 30 or above 30, and your gender in this room, I get like 5 counts, male above 30. Yeah? Everything else below. What does this mean later on? What do I want to convey as a message? I have a few old people in this place. The ones who are below 25 will concur and agree with that. I'm going to look at Woody right now because you're laughing about that. But I'm trying to polarize in a humorous way. So you see, you need to be careful what do you want to explain later on with your data, turning that into information. If your data is crap, which is the technical term for miserable data, yeah, you just can't produce gold out of it. You can't. You rather stay away from that and say inconclusive data, we cannot make a prediction on that. And if you're really being pushed, make sure that you explain in an honest way as a disclaimer that this is really not working. I did that recently on a community project. I said, the way this is working out, there's so many errors, a systematic error. It was like putting addresses on a map. Depending on how you did that in the workflow, you produce different outcomes. Yeah? And then using that in the context, let's say, on voting districts or census tracts where people live and how much income and all that, I literally said, this is for visualization purposes. You cannot draw a conclusion from that because there's such a systematic bias in there. I never heard back from those guys. Can happen. It was a cool project, cool idea. But yeah, geocoding. Give me a bunch of addresses, put them on there. I'm like, all right, fine, I need to best accurate results. Here, street number, street name. Yeah? This is a street, this is the street number. If your system is referenced the right way, You put that dot right on top of the building. It's a so-called point address. I'm really finicky about that because I did that as my doctoral studies. I wrote software that puts points on top of the building for Cincinnati. Well, it was, at that time we were better than actually Google. So, but if you don't have that information, just say Bedford Avenue, you're going to put that somewhere along Bedford Avenue as an example. If this is the house, without the house number, it could end up here along the street. You ever try to find directions for some countryside and put the point like 5 miles away from the house you're actually looking for? It's because it's referencing along the street. That street segment is that long. House number 50 is going to be 50% of that segment, of that street. House number 75 will be 75% along, relatively along the street. They got better over the years. So 10 years ago, 20 years ago, I was Stone Age. Like, good geocoding, good data referencing, if you have been good enough 15, 20 years ago, you made millions of dollars with that. Before we had all this mainstream, what was it, Alta Vista, Google, Yahoo, and all the maps. MapQuest, does MapQuest still exist? Yes, Woody?
When my wife and I went to London a couple years ago, we used our phone to navigate the city, and we were walking to Harrods. I think I'm saying that right, that where all the women want to shop. Anyway, we were walking, it said 2 miles. 2 hours later, 2 hours, it was like an hour, 45-minute walk. 2 hours later, we were still 2 hours away because I don't know, our system from here didn't work over there. So we had to get them out. And the point is the geographic street, these mapping points, address points, it didn't work over there for whatever reason. It was crazy. So it was better to use just a good old-fashioned map because our GIS system did not work great over there.
On the smartphones, yeah. What people don't forget is your smartphone is using not just GPS. Your smartphone is using every wireless network around you to triangulate a better position. They even say the Bluetooth part is giving a better positioning, yeah? Because it's not just GPS, but it's also the cell phone towers you are included in there. And it takes 2 to get a relative and 3 to get pinpoint down location. And you will see if you look at cell phone towers, they actually are in hexagons.
Mm-hmm.
Yeah? All cell phone tower world is hexagons. It's not grid mapping like squares, it's hexagon coverage. Why? Because that is a spotless spotless coverage. Really cool thing. On that note, when we talk about political boundaries, still need to write a blog about that. Gerrymandering political boundaries and set them by ideas and not by certain scientific methods. Let's do hexagons. There are a whole globe is playing computer games, yeah, based on hexagons. Why can't we just say, okay, fine, we start in Key West and build hexagons, and X amount of hexagons is your voting district?
That would be great.
It would be fun, but where would you place the first hexagon? Yeah, is it going to be Hawaii or is it Key West? That's going to be the next part. Just in terms of geographic boundaries, how you organize your space. Think about that. If your regular boundary doesn't work out anymore, what do you start doing? You put an overlay grid on it, squares. That's the first intuition you do. If you need to organize something that is irregular shape, you're going to use squares as a grid. You're not using hexagons because you're not really exposed to those. In the old textbook, and I think in the new one as well, is an example. It's called fishnet. So whatever you have as an exercise, California is the example, you produce a fishnet, which is a bunch of squares. And you try to organize your space and your data with that. The example I showed you with the forest fires, the blue and the red. Dichromatic. Well, what you remember is dichromatic, blue and red, and a bunch of squares. Again, I mentioned that graduated point markers as symbols. So crime counts here by the address. Apparently here's something going on, here's something going on. And all over the place are little examples, like 1 or 2 times in that report. But apparently you have some epicenters. What's going on here? Yeah? Then you could say industry-specific markers. If you particularly go to Europe and you get a map to drive around, you can see different markers. I think those are churches. Markers. Like a solid point with like a flag.
Looks like a golf course.
Looks like a golf course, but it's probably not a golf course. Yeah? But you also can say, no, just use a dot. Why? This is easier to read. Depending on what kind of work you do, you don't care about the fancy marker. A dot is just good enough.
Right.
Most of my work is data management. I really don't care if that dot is a square now as a symbol, or a triangle, or a 3D little bus stop. We'll get to that. It's kind of funny. You can pick out some symbols. I don't really care. For me, it's a dot. And a dot is usually like simply 1 point in size and purple. I like purple. I use all my data I edit is in purple. It's just a thing I picked up years ago. Speaking of colors, if you use pink in this color scheme, pink is not a color, it's a grime. For mapping, it's a grime. No? I had pink.
So no pink.
It's a grime. I had that. I made that comment before we had this pink revolution. Everyone was wearing pink. And I had undergraduates submitting literally their assignment printed out, full of pink, or asking me for help, and the whole screen is pink. This is a few years ago. I'm a little bit closer to a heart attack age, so don't do that. No? All right. Point markers here again. This is an example here: weapons and guns, burglaries, and narcotics. Just to give you an idea, if you do some criminal justice work, you can map that out with different symbols. Particularly in the age of iPads and smartphones, all these nice fancy symbols help. You can see that if you look at ArcPro versus ArcMap for desktop, which are two different programs. They say ArcPro is not supposed to replace ArcMap. It will over time, because everyone wants to be in the cloud, everyone does cloud work. But there are different things. I still see ArcMap as bare knuckles mechanics workshop. And the other thing is cool, the iPod generation again. Here, click on a touch screen, because it's really built up. Say, hey, click, click, click. I don't care how the symbol looks like for kernel density. If I want to map density of points in space, and I use a specific statistical function that is kernel density, I want to execute the command kernel density. In the worst case, I open up a screen and type in kernel density and use command line. Yeah? The internet, as funny it is, it's built on command line. At some point of time, someone was writing code and said, fire it up. Hello world is the most famous sentence in the internet. Yeah? All right. So you can see there are different ways to symbolize a point. Okay? I'm going to run through this because its pattern is the same now for point, line, and polygon. I'm more than happy to share these with you so you can actually take a look at this, because this is like visual memory. Like if you see it once, it's great. If you see it a second time, it's perfect. Symbolizing lines again. This is again the idea, material from the textbook. You can see downtown Pittsburgh. This is the park. This is the Pirates Stadium. Yeah. If you've seen the movie, what was it, Preacher, Guy Preacher? No, what was his name? Jack Reacher. Jack Reacher. This is where the whole thing goes down. Here with the stadium, and here's the parking garage with the weird shooter. And Andy Warhol Museum, you see it if you ever make it to Pittsburgh. It's fantastic, 2 hours or 3 hours of your time. Do not underestimate that stuff. It's really mind-blowing. Okay, this is my field trip recognition. All right. Displaying lines, you can actually make sure that you choose certain symbols or symbology for that. Do you really need all the little details of the minor roads in this map? Probably not. If this is about showing transportation materials, the major roads in Pittsburgh. Yeah, here's the so-called incline, which is also great for sightseeing. Would you go?
The Mount Washington is what it's all called. It's very, you can see the sky, the city skyline.
Yeah, it's really cool. And it's actually west of the city, so if you do that in the evening, you have a perfect sunset set up on the city. I don't really like the team there, but the city is great and the people also. Are you angry with me again?
I mean, I think.
I made a
think
comment
it-
about you, Chess.
I think it's the opposite. I think the teams are great, and like it's just a mixture of people. I feel like it's
Okay.
kind of That was my opinion.
You know, I'm just
Yeah, I know
giving you a hard time here. Okay?
You are.
Okay.
You are.
Yes, please.
Where do we source the visual standards for this sort of thing?
There are ready-made templates for us. So we can actually find these guys in a symbol selection. But it's actually, if you click on that, if the data feeds the right way, the attribute table, and it says, well, this is, let's say, an interstate, it should symbolize that by the so-called category or grade of the street.
And that's is that the on-prem application or is that the cloud?
That's all over the place.
Okay.
That screenshot is actually our command for desktop. So we will get there. We'll get there. It's just a notion that you can declutter this and then you can say, okay, fine, based on the size of the streets and sometimes of the priority of the streets, you have different spectrum, thickness, or even color code. Yeah? So it's actually funny because sometimes I use the interstate to show an extreme boundary for, let's say, mapping, for editing. You say, okay, fine, this is part of the separation. Even if it's just a small road, let's just colorize it as or symbolize it as a big interstate because of in the process, the importance in the process. Are you really angry with me right now?
No, I'm not. I'm actually trying to figure out what the map is for because you're saying it's kind of busy. So I'm trying to like visualize, like from what I remember and stuff. Because obviously the darker lines are the highways.
Yep.
But I'm just confused at how they've separated the gray line. I'm confused really what that is. That's not county, obviously. And it's
No, it's
not,
streets.
It's not. Oh, it is.
It's the streets. This is if this is the park
Main Street.
and downtown, and this is the stadium area,
Okay.
so it's major streets. Yeah? So now we just switch back to the idea, okay, after lines, points, lines, there's polygons. Now I can see this is that tip here, that was what I pointed out, this is the park. Then you have the building footprints of downtown and some other small parks or the market spots. Yeah? But again, depending on what you need to display, this is an example where you put a boundary around the polygon to show more contrast versus here I will use it for some context. Again, it's the idea of figure versus ground. Yeah? Different examples. Did it switch? Yeah. This is an example of, I have state names, but I have sub-regions. Yeah? So now I could use all the West Coast and call it the sub-region of the Pacific, or Pacific Northwest. Yeah? Or the mountain region, or intermountain west here in this area. Yeah? Et cetera, here as well. I can use that to even transform this later and aggregate data, not just visually. I can physically form other data out of that. Yeah? I can also go then in different maps. This is an example of bad map versus good map, where I didn't really care about the color scheme, randomly selected, and the desktop version does that for you. It's painful. It doesn't matter what kind of data you have, it will pull that in and colorize it like this. For some reason. It's one of those funny things that happen. Versus all these colors here, remember, lower numbers are blue, okay, I can get that. But the green is actually higher quantities, yeah, than this, or quantiles in this case. So there's actually a higher poverty in the greens. Yeah. not really knowing what this means down here, I'm going to read this as this is really bad, the blue is really bad, yellow, greenish, that's okay, and all the red is the other way of bad or good. Yeah? Versus this about poverty, it's clearly defined and determined where are my hotspots areas of poverty in that mapping region. This is not perfect, but it gives you the idea of how you choose a monochromatic scale will enhance the message you try to tell. Is that clear? Crystal clear? Oh, that's monochromatic. What kind of data can you plot? Well, what we usually do is, depending on the purpose, you do population density, or you normalize. Typically, easygoing, we're trying to do population as an example of X amount of things in that area, and then population density is X amount of things by an area. Yeah? It could be car sales, it could be MLS listings, it could be sales price, it could be, well, square footage. Yeah? It could be dollar amounts versus dollar per square foot. Could be expenditures, could be the amount of McDonald's in a neighborhood. Just to allude into our exercise in a bit. Yeah? So, could be everything you can count, you could plot. Yeah? If you have the area associated with that, you can present that in a density. Square miles, square foot, depends on the unit, what you want to plot. Square kilometers. Yeah? Quick example. Again here, this is population. In population 2007 in California counties, yeah, and you can see, oh, there's a lot of things going on. This is absolute count of population in these counties. What's wrong with that map? Absolute photo ball? Or was it a selfie? You know, usually a selfie is with the background.
Were you selfieing back there?
No.
Yeah, he's selfieing you.
No. That's you get a great
So what's
picture.
wrong with that map? This map shows you the absolute counts of population in 2007 within California counties.
The ranges are not normal.
Yeah, yes and no. The system might have chosen them. Nobody really cared about that. What's wrong with that?
Is the map distorted? Is that how California looks?
No, that's okay.
Is that it's long down the bottom? It looks like it got down into Mexico.
The counties should be bigger. The counties don't represent where. It makes it look like that whole county is where all the population is, but the reality is it's not showing the exact location because one county is big, it may have just a small little spot in the bottom.
It gives you that idea between San Diego and LA and San Bernardino is that, yeah? Wow, there's a lot of population going on.
You go out there, there's nobody out there. You go out west.
If you go down there, that's just for a tree. That's no man's land. There's some trees. But, yeah. So you might want to change that and basically say, you know what, I want to show those maybe with graduated point markers. Yeah. So now you can see, wait a minute, this is the dark color here is the same amount per county, but the area displayed is different. So intuitively you would say, oh, this is big, this is not.
Like maybe if you're looking for tax revenue coming in per county, that would be good.
But now in population, if you use that, again, just change that to a graduated point markers, where it draws, let's say, in the center of that county, that marker, you can see now, wow, the Bay Area here, this is actually looks way bigger than this spot. Again, let's say this is still that same number, different context. Then you could use a fishnet. It's a really cool function. If you have to explore data, it's a really cool function. So we basically use a function that says, we'll use a fishnet for everything that so-called intersects with the input feature here. Yeah? So you get all these squares. And you can define them in size and how many you want to have and all that. And then you can actually calculate the population in that fishnet. Do I have that? No. And it should show that later on that there might be no population here versus a lot of population there. Yeah? This is the example, similar technique with the forest fires. Similar mechanism in the back. Yeah? Then population density, remember, things per area, people per area, shows you it's clearly the Bay Area versus these counties down here. Yeah? Remember, you need to have a moment of thought what type of data you want to display. And if you go that route in calculating density, you need to make sure that you know which type of unit you're going to calculate. Coming back to transformations and projections, with the XY that long, if you are in a system that uses lat long or decimal degrees as a unit, you cannot calculate area. Because this one would be maybe 20 million decimal degrees squared. That doesn't exist. 20 million square miles, yes. So you need to find a transformation and projection system that runs your GIS in metric or so-called linear units, feet, miles, kilometers, because then you can square them. Not angular units like degrees. We'll get to that. Another cool thing is population.density. If you use that tool, it's really great for display. Remember one thing, those are randomly assigned in that area. So all these red dots here are randomly assigned. These are not population centers like cities. Randomly assigned. Yeah? Take a million, take a dot size of 100,000, you will randomly assign 10 dots in this area. Could be all of here, could be down here, or all over the place. But if you need to measure certain things and you want to aggregate across, let's say, a bunch of measures, like building height, is a cool way to do that. You have the building footprint, you have laser beams, measures, and you say, hey, I take 20 measures per building and aggregate the average height out of that. Might be able to do that. I actually have the data set done, but maybe I show you how to do that. Huh? All right, let's run through this. We're going to do this a little bit in an example later. We're about to get done. Numeric scales. Well, I talked about visuals. I talked about colors and saturation and gradient symbols, all that. This is about now where you draw the breakpoint for those numbers. Ryan said, okay, those intervals, the ranges are wrong. The way you set your breakpoints between those intervals is important. Here, right now, you can see 1001 to 2000, 2001 to 3000. Why? If I would write 2000 till 3000, I might count 2000 double. Or I don't tell exactly where it belongs. Okay? Breakpoints are different from quantiles. Yeah? So we can use that and have the system actually say how many breaks we want. Depending on the data, a manually selected numeric scale of breakpoints might be better than the statistically accepted selection. Yeah? Depending on your data, what do you want to convey? If this is educational data, you might want to show quantiles. Equal intervals, as an example, could be the idea of using median income per household in steps of 10,000. Whatever you have in your data behind, you say, I'm doing $10,000 steps. Huh? So you can actually say then, okay, fine, apply it in. It slices and dices automatically. We'll go through those exercises. I just want to show you that there are so many little options you can choose from. And we go start step by step to learn these options. Yeah? Again, my job is not to cause anxiety attacks. My job is to keep you calm and easy going through the software and the technology behind it, and the knowledge behind it. Yes?
Just curious what your opinion is on like the amount of intervals. You know, like keeping that level low and not making it too busy is like maybe 7. I get it's completely dependent upon what you're trying to grasp.
That's actually if you go through a geography major in Germany, you actually have to go through a bunch of cartography classes. And my old cartography professor, Dr. Brigitte John, we have a love-hate relationship. Awesome. Her answer would to be that I don't care, take 7. Yeah? If you would take 8, you have a problem. In terms of showing groups, see this is 7 here again. Odd numbers, for some reason, are better to display and to differentiate. Yeah, black and white, fine, it's 1 zeros. Yeah? But the third number could be no data. So you have no data, and then 0 and 1, it's like gender. Male, female, no data. Yeah? If you want to map that out. Would it make sense for gender to present 7 or 10 options, or 11 options? Not really, but that depends, because you might have a data set where the variable gender is male, female, do not want to answer, or gender fluid, identify as. Yeah? And you give those subcategories. If you want to do in-depth psychiatry, psychology, social science work, and map that out in your population, I would expect gender more than just 0 and 1, female, male. Yeah? So it really depends. Would I map out with 7 categories income? Probably not, depending on the message. If you want to do, let's say, an example of disposable income in Broward County, I think 10,000 steps are good because you take a look at the basis of your data. That's usually what you do. You look at the minimum, the maximum, and pretty much the distribution of your data. And then you start slicing and dicing, depending on it. Yeah? So it might not be the case that everything is equally distributed. It might be that 10,000 people have $1,000 income left at the end of the month, and only 2 people have $1 million left. Would you present that, and depending on how you choose this, you can present this in a different way, or you just say, I'm doing equal intervals, 10,000 spots, but then you end up in like hundreds of categories. Or you say at a certain point, I have outliers, this is the important keyword here, outliers, and say, let's say, in disposable income, the majority sits between 0 and 1,000, or 1 in 1,000, yeah, and let's say $25,000. In this case, I would probably take, playing with the data and the mapping, would probably take 5 groups for this, $5,000 steps, and then say,